Hello, 8th grade. Welcome. This is your first ever 8th grade math lesson. This is not how I ever envisioned our math lessons to go, but I am excited. I think if you really put the effort in, I will make sure I do my part that you learn everything you need to know while we are learning virtually rather than in person. So it's going to be a really good year. I'm going to help you get ready for high school so that if you decide to go to a university or a technical college or to work, that you're ready mathematically. So let's get started. If you don't already have paper, please get some. And I have given you a sample at the top here of how I would like you to head up your paper. At the main top, I always have done chapter section. So this would be like chapter 1, section 4. Now instead of calling it a chapter, they call it a topic in our new textbook, but it's the same. Chapter 1 or topic 1, section 4. This also has your name and the date on it. I asked you to get a math binder. If you don't have a binder, that's okay. See if you have a folder or somewhere you could put your math things though to keep up with them all, because we're going to use them throughout the year and it's important that you don't lose them. So if you do have your binder, you can put these in tab 1 if you have your tabs. If you don't, that's okay. If you don't have a binder, see if you can find a folder, but I would like you to keep all of your math things together. As you work on your notes today from the video, I would like you to keep the 3 things in mind that I've included at the bottom. It is very, very important that you use neat handwriting. Your examples should be numbered and complete. Now, while some of you can go quicker than I can, and that's great, I do want you in the notes to make sure you get all of the steps that I include in case you need that practice. And lastly, if I write it, you write it. In the video, I will let you know what you need to write, but that's just my general rule for the classroom. I'm sure you remember from last year, so make sure you're not skipping any of your notes. So make sure you've headed your paper at the top, 1-4 with your name and the date. Today is 9/1/20. We're officially into September. This is our lesson overview. It has the math standard on it, which is probably not anything you're interested in, but that helps me. I have a list of standards that I'm supposed to teach you in 8th grade. It does have our learning target on it, which I like. I think that kind of helps guide us. Our learning target is right here. Students will be able to find square roots and cube roots of rational numbers. Now think about that term, rational number. That's something that you heard last year. Can you remember what a rational number is? If you can't, it's okay, and if you did, great job. A rational number is just a positive or negative number. So we are going to be finding square roots and cube roots of rational numbers, which is whole numbers. And first of all, we're focusing on the positive aspect. So we are going to be finding square roots and cube roots of whole positive numbers. Let's get to work talking about square roots. So on the front of our paper, under our name, I'd like you to add a bullet. And I would like you to label it square roots. And then we're going to make this T-chart. And I call it a T-chart because it kind of looks like a T. On the left side of the chart, let's label square root. And on the right side of the chart, let's label perfect square. So those are 2 new vocabulary words that you probably haven't heard before. It's okay if you haven't. It's great if you have. But those are 2 new vocabulary words. On our square root side, let's number from 1 to 15. And I probably will not be able to fit 15 on my screen, but I can do another slide. So if you want to go ahead on your square root side, let's label from 1 to 15. That's a very ugly 4. I got 8 on mine. I will do another slide for the rest, but please go ahead and number your table 1 to 15. We are going to find perfect squares for the square roots 1 to 15. Now, a perfect square is called a perfect square because it's found in a certain way. When we square something, that means we multiply it by itself. Usually that looks like a little exponent of a 2. So if I have 1 is my first square root, and I'm going to find its perfect square, I'm going to square that number. So 1 squared equals this big number called the base times itself. So 1 times 1. Well, 1 times 1 is 1. So for a square root of 1, 1 is also the perfect square. I'm going to do the same thing for 2. To find the perfect square of 2, I'm going to square it. 2 squared means this big base 2 times itself. So 2 times 2 is 4. For 3, I'm going to square it. So 3 squared, which means the base, or the big number, times itself. 3 times 3 is 9. So that means if I have a square root of 3, its perfect square is 9. For 4, 4 squared equals 4 times 4 is 16. Now, if it's not on this list on the right, it is not a perfect square. So 10, not a perfect square. 12, not a perfect square. Both of those are square roots, but they are not perfect squares. All right, if you would like to pause the video, you can, and go ahead and fill in the rest of the numbers through 15 if you can. I went ahead and completed my chart while you were working. If you need to pause, you can to get caught up with me. You may have worked ahead and you just need to check yours. I do want you to notice here in the middle where I do my work. You don't have to do this every time. I just wanted to show you where my perfect squares come from. These perfect squares, 1, 4, 9, 16, 25, 36, 49, 64. That's the end game. That's what you need. This stuff in the middle is just how I got it, and I want you to see how I got it. Sometimes I do have students who, instead of multiplying the base, which is the big number like 8, instead of multiplying it by itself, they'll multiply it by 2. So I have seen that happen. That's a pretty common mistake. Do your best not to do that. The squared means you multiply the base or the big number by itself. So please make sure you finished through 8, and we're going to complete our list through 15. I went ahead and completed the rest of the chart. So on the front of your notes, you should now have a chart with square roots from 1 to 15 and perfect squares from 1 to 15, which turns out to be 1 to actually 225. Let's do some practice. So under your chart somewhere, let's do practice problems 1, 2, and 3. We are going to find the square root, which means all 3 of these are perfect squares, because that is the inverse. If I have a perfect square, I find the square root. That's like an inverse operation. If I refer to my list, maybe, if I need to, I know that 121 is 11 times 11. So my perfect square is 121. The square root of that is 11. For number 2, for the square root of 36, that is 6 times 6. So The perfect square is 36. The square root of that is just 6. Number 3, the square root of 196. 14 times 14 is 196. So 14 is the square root of the perfect square, 196. And all of those could have been found on your table if you needed to check your table instead. If you need a break, it's okay if you want to take a little break. If you don't need a break, that's okay too. If you would please flip your paper over, we're going to talk about cube roots, and I would like you to make that chart on the back of your paper. Now, we are not going to make it include so many perfect cubes. We'll just go to maybe 8. So we're making the same T-chart. This time, instead of a square root, we have a cube root. And this time, instead of a perfect square, we have a perfect cube. So I'm going to go ahead and make my list of cube roots to 8. So think about this. If a square root is 2, how many do you think a cube root is? It's 3. Sometimes people say 4 because they say a cube has 4 sides. A cube does not actually have 4 sides though. A cube is made up of squares, and squares have 4 sides. So I do get that sometimes. If you were thinking that, I see how you got that. But a cube root means 3 times. If you've ever saw a little 3, that means you're cubing a number. So if I'm going to find the perfect cube, that's like saying 1 to the 3rd, which means I'm going to multiply my base, or my big number, by itself. But this time, instead of 2 times, I'm multiplying it 3 times. 1 times 1 is 1 times 1 is 1. So my first square root and my first cube root are exactly the same. They're both 1. So 2, I'm going to cube 2, meaning I'm going to multiply the big number, or the base, 3 times. 2 times 2 is 4. 4 times 2 is 8. If you need to do those in a calculator, you can. There's also good old-fashioned paper pencil. So 3 cubed means my base, 3, times itself 3 times. 3 times 3 is 9. 9 times 3 is 27. 4 cubed means the big base, 4, times itself 3 times. 4 times 4 is 16. 16 times 4 is 64. Okay, I'd like you to pause the video. I would like you to see if you can finish completing the T-chart. So I finished the chart. I hope you finished it too. If you didn't, it's okay. I promise that you'll get the hang of this. I have included the work in case you need to see it. The work is here in the middle. Now my perfect cubes are these on the end. This is the purpose of the work. So my perfect cubes are 1, 8, 27, 64, 125, 216, 343, 512. Our next 3 examples ask us to find the cube root. These are perfect cubes. You will notice these are also under that same square root or radical sign, but this time they have this 3. That little 3 is what tells me I am looking for a cube root rather than a square root. So I can refer to my list if I need to. I know 512 is 8 cubed, meaning that the cube root is 8. For 125, that is 5 cubed, meaning that the cube root is 5. For 27, that's 3 cubed. So for the perfect cube of 27, it has a cube root of 3. I have a couple word problems to finish us up. You do not have to write this whole problem. Let's read it together and we'll write down the important information. Number 7, Leah is building a birdhouse for purple martins, birds that prefer cubed-shaped birdhouses. What are the dimensions of each square piece of wood Leah needs to build the 216 cubic inch birdhouse? So for number 7 on your paper, let's write cube shaped, and then under that let's write 216 cubic inch, and then write each square piece with a question mark. So pause the video till you get those 3 small things written down. Because this one is asking for cubic shaped and it is a cubic inch birdhouse, cubic means 3, so we are looking for the cube root. So if I have 216, I am looking for the cube root of that. I get that from 6 cubed, which means my answer here is 6. Each square piece of wood would need to be 6 inches long to build the cube-shaped birdhouse. Here is our next example, number 8. Once again, you do not have to write everything down. Let's read it and figure out what's important. Sean cuts 1 sheet of colorful poster paper to cover the bulletin board exactly. What are the dimensions of the poster paper that will cover the board exactly? Find the square root of the area to find the side lengths of the bulletin board. So let's write about our area. Right over here in the locker, it tells you that our area is 144 inches squared. So please write that down. And then I would like you to write side lengths, question mark. So that's what we're looking for. Now, do you see how this area is in inches squared? Squared is my giveaway for square root. So what I have is the square root of 144, and what I'm looking for is the square root that gave me that perfect square. They're asking me to kind of find the answer. 144 is a perfect square. It came from 12 squared, meaning that my answer is 12 inches. Number 9, a cube-shaped art sculpture. Okay, cube-shaped means I know I'm going to use cube root. Another giveaway for that is volume. Volume is always in cubic units. So a cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube? And then it gives me like a little answer sentence. So would you please write on your paper, V equals 64. Now, to represent cubic feet in symbols and abbreviations, I'm going to put FT for feet, and then cube is the little 3. So what I am looking for is the cube root of 64. 64 is a perfect cube that came from 4 cubed, meaning my answer is 4. So the length of each edge is 4 feet. Number 10, this is our last example. Emily wants to buy a tablecloth to cover a square card table. Okay, so write that down, square card table. This means I'm going to be looking for a square root. She knows the tabletop has an area of 9 feet squared. So let's write that also, but let's write it with our abbreviations and our symbols. So I'm going to abbreviate A for area. Area is 9 square feet. So 9. FT for feet, and squared is a small 2. What are the minimum dimensions of the tablecloth that Emily needs? So if I'm looking for the square root of 9, that comes from 3 squared. So her minimum measurements are 3 feet by 3 feet. This is the key concept box that is included in our new online series. You do not need to write anything down from this key concept information, but if you need to, you can refer back to this. It should also be in your online series, although I'm not totally sure how to work it yet. I just have the bare minimum for now. But the key concepts that it wants you to take away from this is that the cube root of a number is a number whose cube, or which means multiplied by 3, is equal to that number. So for example, 5 times 5 times 5 is 125. And those are inverse operations. Cubing a number or taking the cube root of a number is the inverse. And at the bottom, the square root of a number is a number whose square, or multiplied by 2, is equal to that number. And those are also inverse operations. Squaring 2 and taking the square root of 2 is an inverse, sort of like addition and subtraction, or multiplication and division. So this is your key concepts, the 2 things that they wanted you to take away from this lesson 1-4. You have 3 assignments for the rest of the week related to these notes. You can find them in modules on your Canvas. Those modules will link you to our online textbook, the Realize stuff. It used to be Pearson, and now I think it's not. But they are supposed to be interactive practice. So I don't know exactly how interactive. From the teacher point of view, they are very interactive. Kind of like Study Island gives you like reasoning behind if you missed it. So please take the time, if it does give you some reasoning, to actually read it. Friday's assignment is to compare and contrast square roots and cube roots. And I've given you some vocabulary in the video that will help you do that. Everything should open today for the rest of the week. So you can work on it ahead if you want, or you can just work on it on the day it's due. And if you absolutely have to, you can work on it just a little bit late. I know we all have things going on. They ask that we give you 1 week. So please make sure, if you are having to postpone your assignments, you're completing them within 1 week of the day they were assigned. And if you have any questions, just let me know.